Hello everyone, let's wait a few more minutes and then we can start. Okay, we can start. Hello everyone, welcome to our today's session. And yeah, so here's the agenda for today. First of all, we'll start with one small example about using switch statement. Yeah. So just the last example before we go to arrays. Yeah, we'll also just quickly have a short overview about switch statement, and today we will speak about the arrays, and we'll explain what the arrays are in Java and in general in programming. So that's the common topic which is used in almost in all the programming languages. Then under this topic we'll discuss how to create and initialize the arrays, how to work with them, what is the index of array and the length of array. We'll talk about it. Yeah, how can we use them, and also it's a really small topic about two-dimensional arrays. And this may be small. It's like let's define it as a small home task for the next session. Please send me the topics, maybe the points which are unclear for you, and you want to discuss more. You can do it just privately, write it to me or in general chat, so we can discuss topics next time. It can be whatever you want, any topic, any complicated or not complicated question, we can discuss together next time. So that's about the agenda for today. So let's move on with a small example, and then we can finish our switch statement. So yeah, just as an example, let's define the let's create the class where we will simply switch between the desks in the airport. So, small example. Let's imagine we will use scanner, which So for the input, again, we can simply use the approach we used before. So yeah, the idea is that we have the destination we want to fly to, and based on the destination, we will go to the corresponding desk and just checking. So let's start with the destination, and first of all, let's declare scanner, and then we will determine the destination. So we will enter destination. Of course, again, we can close the scanner, and so yeah, another method. So we will, which will check in as. So the method. And so here we have the company name, A1 name. And here we will have, let's create a static public variable which will point us that we just checked in the corresponding airline company. Static string. Start with initial value. So here we will pass the airline name. So this will store us the value where we, which airline we use. And so here I said I can use the full approach. So this is equivalent, again, this is equivalent approach. If we refer to static variable of the class, then we can simply use this variable, or we can also the same approaches if we use the class name and then the variable name. And I'll print out that we just checked in. Okay, so as the airline name. So yeah, now let's go through the options we can fly to. So we switch the, okay, maybe let's use this option, which is easier. And so based on the destination, we can, if the destination is simple option Berlin, then we will check in to using Lufthansa, for example. Check-in, sorry. Check-in. Check-in using Lufthansa. If we go to Helsinki, for example, then we Then we use thin air. Just if we go to town, for example, then we check in using air Baltic. So let's add one more option. If we fly to Oslo, then we use SAS. And yeah, of course, brakes needed. Don't forget about the brakes. And yeah, otherwise we can print that and no airline exists, no airline fly to this destination. One available, yeah, simply no airline available for the destination. Alright, so now let's run this. Let's run this program. So, oh yeah, of course I haven't printed out to enter the destination. To your destination. Alright, so now let's start it again. So I would like to go to Berlin, and then I checked in Lufthansa. If I go to Oslo, checked in SAS. So based on the destination, we will the corresponding attribute will be passed to the check-in method. So that's the way how switch statement works. So one key and different cases for one key. The key is destination, and then we can have multiple cases. Multiple options for the destination, for different destination. Alright, so that's about switch statement. Yeah, so again, in general we have switch, key, then the beginning of the block. Then we have multiple cases, and after each case we have break statement. Without break statement we will go to the next case, so it will not stop us at the case we are currently in. So in general, case starts with case and finishes with break. Yeah, once break is reached, it means that the corresponding case is over. So this is the same as we have blocks. So if we have one bracket, it means the start of the block, and another bracket means that the block is over. That's the end of the block. The same is with the case, but not without using the brackets. Here we use the call, dots, and we finish with, we start with case, so that's the beginning, and break, that's the end of the case. So yeah, that's it about switches. To be honest, switches are not rarely used, but not as often as ifs are used. Yeah. So switch option is a nice option where we have again one key with multiple with multiple options. It doesn't happen so usually, so often, but sometimes it is better approach to use, but not as usually as we use if and else. So this is like an additional point for us. Okay, so that's about switches, and now we will move to one of the most important topics in all the programming languages, not only in Java. And the topic is arrays. So, yeah, why it is so important? Because, okay, maybe let's start with the example. An example from real life. So imagine we have this is the Christmas now. Not everyone, but most of people want candies, just like a present or simply to eat candies. So, okay, imagine we have the box of candies, and so like this type of box of candies. So, what are the properties of this box of candies? As we can see, we have a fixed number of slots. Of places for the candies. So there are 6 places, no more. We cannot add another place, and we cannot remove any place from these. So we have fixed number of the places. In this case, it's 6. Yeah, of course, you can imagine that there are boxes with 8 or even 7 and so on. Number of places to put the candies in. So in this case, fixed number. That's one property, so we cannot remove it. If we have more spaces for places for the candies, it means that this is different box. We cannot use the same box. Just this box as the object cannot be changed. The structure. We can change the values of these the content of these slots. So we can add candies, we can remove candies, we can replace candies, and so on. But we can change the content. So in this case, the content is limited. Just maybe one property, which is maybe not the property we want to think about. Is the number of candies is limited here. This is not the option in real life. In programming, this is not kind of the option not kind of property we would like to talk about. So this is the property let's skip it. But we can, if there's a limited number of candies we can add. But the idea is that we have the slots for candies. So the type for items is fixed. So we can add the candies only. We cannot add coffee beans or anything else, just the candies. Now we have a fixed type of the content of these boxes, of these slots. And in general we understand that relation between the box and the candy, the slots is 1 to 6. So we have one box and 6 slots are related to this one box, to this one object. And if we go a little bit closer to the programming, then the box is variable. So this is the variable which has 6 different spots. So this is one object, one variable. Everything here is considered as one variable, which is the box. And inside the box we have the contents. And inside each slot we have the elements. And the number of these elements can be different. In this case, in this slot we may have more candies than in this. And the same with other slots. Yeah. So number of candies in each slot, we consider this number as the value. So we have one variable, 6 slots, but in each slot the number of candies is different. And if we imagine the hierarchy of this, so we have the array, the box, and inside the box we have the elements. We have one element, one slot, second slot, third slot, and so on. So there are multiple slots inside the box, inside the variable. So we have multiple elements inside the variable, and in each variable we have the values. Yeah? So there's one value, there's another value, there's another value. So this is the structure: general variable, box, and the elements. First element, second element, third element, and so on. We have multiple elements, but the number of elements cannot be changed for this particular box of candies. And so yeah, this is the way how we can describe the arrays in programming. So yeah, why we need arrays? We need arrays to store the data, as it usually happens in programming, to store and to move the data from one place to another. Yeah. So just it is we can just, if we talk about simple variables, then we have two ways of maybe let's be more detailed. We have three ways. Yeah, we can have scalar value, and we may have array. So it means that we have multiple elements inside this array. And also it is mentioned there's the object, but array is also the object. So I already mentioned that we consider the box of candies as the object. So yeah, and this is the array, and we can declare it using the type. So each array has the type. This is what I said for the for the candy box. So the type will be candy. In this case, it's integer. So it means that this is the list, and the variable which contains the elements. Like in this case, there are 5 elements. So we can quickly write it in Java. Package. So small int 5. So yeah, we have int, declare it as integer, and there's array. So call it array, and we can declare this array with the elements. Need the numbers 10, 53, and so on. So this is the way how we can declare the array. Yeah, we're using the brackets, and inside the brackets we put the values of this array. Interesting thing is that there are two ways of declaring the arrays. So this is the first way, and the second way is if we put the brackets after R, in this case after the variable name. So this is the equivalent approach. We'll have the same result. So yeah, this is how we can declare the variable, the variable which is the array. Yeah. And yeah, there's also the way of storage as the object, but this is the data type which we'll talk about object-oriented programming. But actually, just before we start talking, please note that array is also the object. So the array is not the same as the primitive type. So if we talk about such primitive types like integer, or character, or byte, or double, or float, so these are the primitive data types. So it means that this is the simple place in the memory where the variable is stored. For the array, the storage is different, and the structure of the array is different. So this is not just one simple primitive variable. Array contains the elements, multiple elements. So it means that there are 1, 2, 3, 4 variables here. So in this case, this is the array, and this is the array with 4 elements, and each element is the variable. So so you may understand that the structure of the array is much more complicated than just simple variable, because again, variable is 1, with the value, but the array is the object. It's the object with the values. And the first thing what you can see is just maybe again, if we talk about one small integer value, variable. Let's mention it now, an integer value. If we want to just do any actions with this variable, we can see that there are no options, there are no methods we can call from this variable. We cannot just have any conversions here, and any actions we can do from this variable. We can only use it as the variable with the data storage. And we can assign new variable, we can do some checks and so on. But if we, so again, as you can see from here, no methods we can call, no properties we can check here. So that's because this is primitive data type. So there's no methods, no properties, just one value. If we talk about the arrays, from the arrays, this is the object. So this is the object, and it means that it's not a primitive data type anymore, so it's not just a single value. That's the reference data type, so this is the object. And right here, if we call the method, if we just press dot, it means that we want to access the methods from this object, from this variable. And we can see that there are some options we can select. Maybe the most important options are length. So using length, you can get the length of the array. Just we can quickly check it. So if we print out, we'll see that the result will be 4. You'll see that the result is 4. So this is the number of the elements in array. If we add one more element, we'll see that there are 5 elements inside the array. And so this is maybe more complicated thing. We'll talk a little bit later about toString. That's also not it's also the thing the method we'll talk about when we talk about object-oriented programming. And but from the array, maybe the two more most important, just maybe not most important, but one thing which one method which we'll definitely need to use is length, to get actually the length of the array. Other methods are related to any object in Java. It's the same for the string. If we declare the string, again, as we if we have the string, again, as you remember, the string is also not the primitive data type. We can call the methods from string, and you can see that there are some common methods, not clone, but string to string. Yeah, also the common method you can see in from string in string class. String, there's toString, and from the array we also have toString method. So the meaning is different, and we'll talk about this particular method in object-oriented programming topic. But this is common for all the objects in Java. So there are some similar methods, notify, and so on. So this is maybe the first step when we talk about the object-oriented programming. We have the methods. We have common methods in array and in string as well. So for the array, the must-have methods are length and clone. What does clone mean? We will also talk about a little bit later, even today. But yeah, so the length is must-have. This is not the method. This is actually the variable. Yeah. This is not the method. This is variable. This is the value. Yeah. The variable which has the value to store the length of the array. All right. So yeah. So if we start talking about the arrays. So this is the variable, yeah, one variable with multiple elements. Each element is stored in a specific cell. So we have the cells, slots, as I already mentioned today, and yeah, the numbering starting from 0. So this is a really important thing to remember. All the arrays start with 0. You can ask why in not only Java, but in all the programming languages all the arrays start with 0. That's because of the memory. So if we talk about the memory, the array is the elements of the array are stored in memory. So it's the first element, the second element, and so on. And we start at position 0. So when we read the elements, we start at position 0. So we read from left to right there. That's why we start actually from 0 position, and then we add some steps, and we get other elements. Yeah. So the cell number again starts with 0, and it's called index. So yeah, we have the slots and their positions, and each of them are indexed, so like 1 or 0, 1, 2, 3, 4, and so on. So to get the element, the value, it is necessary to know the index of the element. Alright, so that's without knowing the index, or without using the index, we cannot access the value of the array. So like in this case, even if we want to print the array, we will see that it is not as easy as it looks. And just if we want to print the array, we'll see that we get such crazy things. That's actually the pointer to the memory. So we cannot we cannot see the array using just simple print. To see the values of the arrays, we need to access the elements of the array. of the array separately. We'll see how to do it a little bit later today. So like in this case, maybe let's create this array, a temperature array. So the temperature is 16, 20, 21, 23, 22. Just to be more clear. Yeah. So so yeah, this is on the 0 index, this is on the first index, second, third, and fourth. Okay. Same as here. To access value 21, we need to use the second index. To access 16, we need to use the 0 index, and so on. And how to do it? We will. Maybe let's access them right now. So if we let's print them out. So we use temperature array, and yeah, we use the same brackets, and then we access the index. So in this case, I will access the fourth element. Okay. You will see that I access the fourth element. Same if I want to access the first element, I put index 0 and I get the first element of the array. Okay. This is how can I access the elements in array. So let's talk about the array initialization. So in general case, like this maybe more simple case, we just statically provided the elements of the array. So we know the elements are fixed, and there are 5 elements, and we assign the elements of the array to these values. So in this case, we know that the length of the array is 5. So what? As we can see, we can access the elements using the index. So if I want to change this element, if it's the third element, so I assign a new value to it, and then you can see that as usual, as for all the values, when we assign a new value, we will see that the value is changed. So now this element has a new value. And the question is, what would be if we want to access the, in this case we can see there are 5, so the 6th element. So in this case we will have the exception, and we'll have the exception array index out of bounds. So it means that currently we have the array where there are 5 elements. So it means we cannot access the 6th element. And actually there are no ways. So if we have the array initialized with 5 elements, so it means that this array cannot have the 6th element. So there is no way we can, during the execution of the program, we can assign a new element to this array. And this is just as we remember in the beginning of our today's session, number of places is fixed. There are 6 places inside the box. There can be no more places. And yeah, if in general case we can declare the array, maybe let's to not overflow this class, let's create the class. So in general we can declare the array using new operator again, as you remember, for all the objects, for absolutely all the objects, we need to use operator new, and this will create us a new object, which is like if we talk about the candies box, the box of candies, so this will create us the box, box with 6 slots. So just first example, let's create the variable which is the box with 6 slots. So in this case we can create the array with 6 slots. So yeah, of course need to put and to mention that this is the array on the left side. So now we have the variable which is typed as the array of integers, but as we can see, in general case, during the declaration of the variable, we don't need to mention the size of this object, of this variable. That's because this is not the object yet. So I would like you to understand that object and variable is not the same. Object is not the same as variable. Now, please remember this thing, because this is really important, and especially if we talk about the objects in Java and in programming. Object is not the same as variable. So this is the variable and this is the object. So these are two different things. Please remember this one. This is really important to understand. Again, maybe it's not so strictly that you must remember it right now, but for the future this will be, you will have a huge advantage if you understand this thing. If you know this concept, this is really nice, and you already know the base of object-oriented programming. And the object is not the same as variable. And as an example, here in arrays, on the left side we declare the variable. So this is just the variable. There's nothing assigned to it. Just if we in the craziest way, maybe let's print it out and let's see what do we have. And if we print this variable, it already shows us that the variable is not initialized, but this will actually be null. So this will be empty variable without any object assigned to it. So maybe let's skip it. And that's because of compiler do not allow us. In general, this will be null. So there's no object inside. Yeah. So this is just the variable. Again, please remember that after each session I push the code to the remote repository, so please check, and then you can also check the comments inside the code. So this is the variable, and the object the array is created and passed to the variable. So the variable, again, as you remember, this is the place where we can place the value, and the value is object in this case. So now we have the variable, and we have the object. The object is the array with 6 elements. So the same as for integer values. If we print any of the elements, third element, and we'll see that by default for integer values this will be 0. Yeah. Since this is the initial value for the integers, if we use the string, so by default this will be null. This will be null. That's because string is not the primitive type. So for all the objects and for string as well, the initial value is null. So this is empty object. Same for character. No, for character not the same as for string. We have the character, the same not as for string but as for integer, the same as for character, basically for all the primitive data types. Oh yeah, of course, again I forgot. And yeah, so this will be just empty character, yeah. One empty character. And maybe let's start with integers. So this is the general way how to declare the array with 6 slots. In this case we start from 0 to 5, yeah. 0, that's the first element, that's the last element. And again, this cannot be changed. If you do it this way, you'll declare a new array with more slots. That's different object. Here you created new array is created. New array, new object is created. So in this case, this will be absolutely different object than this one. You actually here we create two different objects, two new objects. Yeah? So please understand this thing. Yeah? These are different objects, and this is not the same array. So the variable is the same, but the arrays are different. In this case, as you can read it from the operator new, this is a new object, new array. So yeah, just if we talk more closely about the decoration, the initialization of the arrays. So on the left side we need to specify the type. It can be any type in Java, it can be primitive type, it can be reference type, whatever you want. Then we have the brackets, the square brackets, which specify us that this is the array. So without them we cannot not use the variable for the arrays. Then the title, the name of the array, the variable name, and you can choose whatever you want, but please follow the namings which are used in your particular case. And then the assignment. Then on the left side we have the variable, on the right side we have the object, the array. Then we need to use new operator, which will create us a new array. So in this case it reserves us cells in memory. Yeah, there are four the cells for four elements inside the array. That's why actually this is the case. This is the reason why you cannot change the number of the elements inside the array. That's because the memory is reserved, and we cannot at the middle of the program just accidentally change this, reserve more space, yeah, because it can already be taken. In this case, if you want to increase the number of the elements, then you need to create a new array. Yeah, and the type, the same on the right side. That's because here again we create new array, so we also need to specify the type of the elements inside the array. And the last thing is using square brackets. On the right side we specify the number of the elements which will be available inside this array, inside this array, which will be assigned to the variable on the right side. So this is about the initialization and declaration of the arrays, and now we can have the break. And after the break, we'll continue talking about the arrays. Okay, let's continue talking about the arrays. Audible, yeah. So yeah, the way how we can. So we previously seen just primitive way where we assign the variables, the values directly at the beginning. In usual case, we don't usually do it directly. We use the assignment inside the code. We usually use the loops, for loops or the while loops. But this is the next topic for us. At the moment, let's take a closer look how we can assign the variable, the values if we know the index of the element. So, as we can see, here, we pass 5 elements to the array. So, just to not overcomplicate, I'll comment it out, and so here we have 5 elements. Let's start with 5 elements, and so here we see the approach when we declare the values directly. We pass the values directly. In the same way, the more common approach is that each element of the array is accessed. So we access the first element, and we access the second element, we access the third element, the fourth element, and the last element. So this would be the same. This is the same if we pass the values directly. So the question from you may be, why we use this approach, not just usually this approach? That's because usually we don't know the values we use inside the arrays. Of course, if we just simply know the 5 exact values we use, then we can simply use this approach. But in practice, we don't usually. We have just some kind of calculations, some different logic where we come to the different values. And as in this case, we use the index and we access the corresponding element of the array. So this is how we declare the elements. We can see it here. So the index, in this case, index 0. Each index with the corresponding element, which has the corresponding value. yeah, in shorten notation, as we already talked about, if we just simply directly access, if we simply directly pass the values to the array. Yeah, but again, we may have some different logic. Just simple case. Now let's just imagine that we have the value, the variable, and let it be Boolean. Just this value different, and based on this value, if it is if the value is not different, then we can simply assign this value. Otherwise, we assign different value to this element. Yeah. So the idea is that based on different logic, we can assign different value. So that's why in this case, just if we have this particular case, then of course we can directly access directly assign the values to this array. That's because in the middle we have the logic based on which the value may be different. So in this case, of course, we can write it this way. So if something like this, it can be something like this, but oh yeah, it is also possible to assign the values directly inside the code, so during the initialization. But again, in this case, we can see that we have different if cases. We have if case with different values, so it's not possible to assign all the values at the same time. So that's why we use the logic, and the logic will give us different results. So yeah, this is about the initialization. Yeah. So as an example, we can, as we already seen today, we can use length variable to see how many elements there are inside the array. So we can use length variable from the array, which will give us the result. Alright, so that's we already seen today. And yeah, the value is passed during the initialization. So once we create the array, this will be the number inside to define as the number of elements inside the array. We cannot skip it. We are not allowed to skip it. That's because the number of elements inside the array is fixed, and it must be fixed. So yeah, this is when array is initialized, the default values are stored in arrays. So again, for the integer, these are zeros, as we already seen today. For integer array, we'll have zeros. For different primitive data types, the corresponding value of this primitive data type, initial value of this primitive data type, will be stored in these values inside the array. For the reference types, it will always be null, which means that the object is there's actually no object, so the value will be null. Yeah, and as an example, for the array, for the integer array, these are zeros, and just maybe one small not trick, but in case we don't know the number of elements inside the array, to access, and we want to access the last element inside the array, we can use we can do it this way. So we can access the last element in the array. Again, we use -1 because the length is actually the length of the array, but the index starts with 0, so it's -1. So in this case, we will access the last element, of the array. So length -1. This will return give us the number of elements inside the array. So this is the integer value, of course. Quickly run the program. We'll see that this gives us the last element. Alright, let's move on with the presentation. So, yeah, this is about the integers and how to get the element. Of course, as we already seen, we passed inside the brackets, we passed the index of the array. We passed the index of the array, and then we access the element from the array. So this is what we already seen. And yes, so as an example, we can use these elements to calculate some things. As it stands here, we can calculate the sum of the elements of the integer array. So let's check it as an example. So let's define the array. Yeah, the name can be whatever you want. I use array. This a double R. But again, this is the variable, so you can name it as you want without any specific restrictions. So this is what would be 5 elements. And then we can assign values to these elements. So it'll be something like 34. Elements. So this is the 4th element. And now we can use these elements as the simple variables. And each element is the variable inside the variable. So we can, for example, we can calculate the sum of all these elements. And for example, so again, one variable, set another variable. Yeah, it doesn't matter how we access them. We can switch the sequence. So yeah, now you'll see the sum of all these elements, and it's 164. So yeah, this is again we can do any actions with these elements as we want. And we can, in the same way, we can multiply, and we can subtract, we can divide, any action we want. Same as for all the integers. Just the same way as we do it for all the integers. And yeah, before we continue, just a small reminder. As you remember, in first sessions, we already talked about the array, which is the array of the arguments passed to the main program. So this is also the array. As we can see, this is also the array of the strings. And just quickly, as you remember, let's create a new class. Input arguments. So again, just a small reminder, if you remember, if we don't have main method, we cannot run the program. Main method, this is the starter of the program. This is the starter of any Java program, and we can pass the arguments to this program, starting arguments. So we have a starting method, and we have the starting arguments. So this program, so the same way. We can access this array also the same way as we can access any array. We need to pass the index, and then we will access this argument. So again, if we just simply run the program without passing the arguments, we'll see the same error as we have when we attempt to access the index, the element, the index which does not exist. Like in this case, we have not provided any arguments to the program. That's why we have this error, because we don't have the first argument. But if we go to our configurations and we pass the argument, so now we can run the program, and we can see that here's the first argument of this array. So then we do the same for multiple arguments, and then we can again go to run configuration, and in this case the second value, third one. So now we pass these three arguments, and we can see that we can use them directly inside the program, the same way as for all the arrays. So now we have the input. Also, how can we just primitive check to not like in this case, we can see that if I attempt to access the last argument, then again, as we remember, we will have the error. And just a primitive check how to escape this error, we can check if this element exists like in the most primitive way. Again, a little bit later when we talk about the exceptions, you will see that there are different options. How can we escape this exception? Just the primitive way, you can check the length. So if the length is greater than 0, it means that we have the first element, right? So then we check the first element. If it exists, then this will print us the first element. Same as for the second element, the same as for the third element, and same as with the last one. So this is just a primitive way. How can we check if the element exists? So in this case, we checked the last case. The length is not greater than 3. It means that there are no more than 3 elements inside, and we don't have the exception. That's because this if is not fulfilled. So we can use when value to check if actually the element exists. And in this case, we don't go outside of the array bounds. So the index will not be outside the array. As an example. Alright, so yeah, in case you have any questions, please ask. And also, yeah, here you can see, just in case we want to sum the values of the array in a more general case, yeah, like if we have hundreds of students, it is not possible to just simply type every line. Yeah, it's not efficient way. We will use loops. Yeah, but yeah, this is the next step. The next topic we will have about the loops. Just to deal with lots of elements. Yeah. Have like hundreds or thousands of elements, then we'll use loops, but yeah, this is the next topic. And also, yeah, it is also possible to just not simply declare one dimension, one list of the elements, but we can also declare two-dimensional arrays. Yeah. So like in this case, yeah, we need to specify the number of, we can imagine this two-dimensional array as the table. Yeah. So we have the table with the rows and columns. Yeah. Just if we open Excel file, yeah. So as in Excel we have the rows and we have the columns. So the same as for two-dimensional arrays. This will be the table with the rows and the columns. You can declare it in Java. For those who are familiar with mathematics, we can describe the matrix as two-dimensional arrays. So the same way, we create new object, we create new array, we specify the type, and then we specify the number of rows and number of columns. So in this case, this is the array of array. Yeah? Array of arrays. Yeah? For each position, for each element in the first array, we will have the array as the value. So practically, again, we have the array. Yeah? We have the array. So we have the array. As you remember, the array, this is the variable with the elements. So one element, and so on. And each element is also the array. So we have the array of the arrays, and we can go the same way with the same size. So in this case, the size for each of this element, the size of the array for each of these elements will be the same. So like the first element is the array with m rows. The second will also have be the array with m rows. Okay. So in this case, there are 2 rows and 4 columns for each row. Okay, in Excel that would be yeah, 2 rows and 4 columns. So this case, yeah. So it's for the array. And the same way as for the one-dimensional arrays, we can access them using the index. So we can access the first row and the first column, like here, for example. So just some 1, and first row, second column, and so on. So yeah, the last one is to go through all the cases. So here we finished the first row, and then we can do the same for the second row. Okay, we can check if we don't go outside. Okay, a moment. Oh yeah, of course. We start my error. We start with 0, of course, and same as for all the elements. We start with 0. For all the arrays, we start with 0. So we will have no errors here. Okay. Also the same way as for the simple one-dimensional arrays. Yeah, as you can see here, nothing special, and just one more dimensional is added. Oh, okay, let's move on with the presentation. So yeah, also decorations really similar. And yeah, we can imagine this as a table, and each row has its own unique index, and each column also has the index. So just to point on the, like in this case, this will be the second row, yeah, with the index 1, the second row, and the third column with index 2. We just directly access the corresponding element. And yeah, the same way as for one-dimensional arrays, we can initialize them using direct assignment. And like in this case, we can use the equivalent approach. Let's quickly second array. So we have, yeah, so here we can simply understand how does it look. So it's 1, 2, 3, 4, and same as here. So just yeah. So a moment. What have I missed here? Oh yeah, of course. I thought, yeah, so everything's fine now. I usually forget about the rectangle outside. So as you can see here, the structure seems the same. We have the elements. We have two elements in our main array. So the first element and the second element, and as I said, each element is array. So we have one general array with 2 elements, and each element is also the array. Okay, again, as I said, the number of the rows should normally be the same. So in this case, we can see that there are 5 elements on the right array and 4 elements in left array. So let's see if we access the 5th element on the 4th element of the first element. So let's print it out. And that should print us 7. That should print us 7. If we do the same with the first element, we can see that for the first element we don't have this element. So that's the maybe small difference. Yeah, we cannot declare the array directly with different number of elements, different number of elements inside the arrays of each element. And let's print out the ones and see what we have. And the one will show us the first index. That's because, again, this is the array of the arrays. So at the top there is the array with 2 rows with 2 elements. Yeah, if we access the first element, for example, then from the first element we can also print the one, and this will print as 4, which number of the elements of the first array, or the first element. And then the number of the elements in the second array. In the second array, that should print as 5. So the concept, I hope the concept is understandable for you. Okay, so that's it about the arrays, and this is about the arrays. If you have any questions about the concept of the arrays, please ask. If not, then we can move. Please ask if you have the questions. If not, then we can go to the next topic. So I haven't shared it with you, but so I will do it now in a moment. So I'll also show the presentation about the loops with you. So as I already, again, please, if you have any questions, some unclear details about the arrays, please ask. So even if the questions are simple, or maybe just if the questions are simple, please also ask. It's really important to not miss any step. But for now, again, if you don't have any questions, we can go to the topic without which we cannot really work with the arrays. Again, as a simple way, we can directly access each element of the array, then assign the value. But in real life, in the more general examples, we cannot usually we don't really know how many elements there are inside the array. So for this purpose we need to use the loops. Yeah. So what actually is the loop, and what's the purpose of this? Imagine that you just not imagine, but you know that every day, if you work from Monday to Friday, so every day you repeat some actions. You wake up, you eat breakfast, then you go to your work. You have the work until just for example 12 o'clock. You have the lunch, and then you continue to work, and you work until it's 5 p.m. or 6 p.m. After that you go back to home. So this is one iteration, and you repeat the same actions. If this is the week, then you repeat the same action for 5 times, from Monday to Friday, as an example. So you have the action which is repeated. So for this case, in Java, we need to just not simply type every single, to not simply define and proceed with every single working day. We use the cycles, we use the loops. So it means that the same action is repeated for some times, and this is basically what Java loops are. So imagine, basically again, what is the loop? The same things are repeated for several times. It can be, again, if it's alarm is ringing, you cannot wake up, alarm repeat, you snooze the alarm to 5 minutes, then you repeat it, and so on. So this is the cycle. And so we can also describe it as the algorithm. So alarm is ringing, it's 7 o'clock, so that's the beginning of the action. Alarm is ringing. Then are you ready to wake up? If no, then we wait for 5 minutes, then we repeat the same action. So this is how we can imagine the loop. And at the end, of course, when you finally are ready to wake up, then we finish the loop and get out from bed. So this is basically what the loops are. And how can we apply it in programming? In programming, we have such things like iterations. And every time, for every, if that's the array, we need to have some actions for the array, and then we need to go through all the elements in the array and assign the variable. And just simple things. Let's create the package. Call it oops. And let's call it the class iterate. So let's quickly declare the new array, and the array will be just one-dimensional integer array. Just values. We create new array. And this is what we still need to do. Let's imagine we have 5 elements inside this array. And so imagine we want to have the array with the values 1, 2, 3, 4, and 5. So what can we do? For this we can create the cycle. And the cycle can be created in the following way. So we declare for, we use operator for. It means that we repeat the same action for several times. Inside this, inside the brackets, here we declare a new variable. Usually we use I. Yeah, this is just must use variable inside the cycle. So if you usually don't need to think about how to name the iterator variable. It is in 99.999% of the cases it is I. Yeah. So this is the first choice for all the cycles. You'll see the variable I. So this is the variable which will point us at which iteration we are. So as an example, so here we declare the variable. So that's the first step. Here we have 3 steps. First step, we declare the variable. Second step is we show until which value, until which case occurred, we will be inside the cycle. So here we point that we will proceed with the cycle until I is less than 5. Yeah. So it means that until I is less than 5, we will be inside the cycle. And the last step is how the value will be changed. So we usually use I++. It actually means that that I will be increased by 1. Yeah. So it means at each iteration. So in this case, as I already said, we will access the element in the array and assign a new value to it. So the value is I. These values, of course. So, and again, the same as for if we have one line of code under for cycle, we can skip using the brackets. Yeah, if we have more than one line, we can use the brackets. So this is the equivalent approach. As the same as for the if one line, we can skip the brackets. If more line, we must use the brackets. Yeah. So this will be the same. If we use the brackets, it's not incorrect, just an alternative approach. Alright, so now so what does it mean again? We go inside for cycle, we declare iterator, yeah, which is I. We check if I is less than 5. Then and after each iteration we increment the value by 1. And of course here we will have one small incorrect detail. So what the detail is, as we can see, the task for us is to just assign values 1, 2, 3, 4, and 5. But which values will be the result? So the same way as we declare the variables, we can print the array. And this approach will be how to see what are the values inside the array. So to see what are the values inside the array, we'll use print line inside the cycle. So here in the first step we assign the values to the elements of the array, and then we print these values. So let's see what there are, and we can see that the issue is that we start at 0. That's because again here we start with 0, so in the first iteration this will be 0, and after each next iteration I will be incremented by 1. So in this case, again, if we add +1, then we will have correct result. Yeah, 1, 2, 3, 4, and 5. So this is how we how we proceed with the cycle. Also, we can have some tricks. We can use some tricks here, since we have three positions. At first position, if we declare I as 5, we'll see that this cycle will not be executed, because again we start with 5, but the cycle will be, we'll go inside the cycle only if I is less than 5. So in this case will never be occurred, and we will not go inside the cycle. And the same way, if we add 4, it means that it will go inside the cycle only once, because only 4 is less than 5. 5 is not less than 5, so it means that we will only be at the last iteration. As we can see, only last element is assigned. But again, usually we start with 0. And also we can add such trick like, again, as you can see here, this, as you remember, if we have comparison operator, this will return as true or false, right? While I'm at the question from Lima, I will answer just shortly when I finish talking about this. So, as we can see here, again, as you remember, first, the first is the variable. The second is, in second position we have true or false, boolean. So which is boolean. Boolean, and at the third position action, which happens after, so that's maybe I will highlight it, after each iteration. So means that if this is true, then we go inside. And the tricky point here is that if we so again, since this is the boolean, we can simply add that this is true. And what does it mean? It means that we will go to the endless loop, and in this case we can already go out of bounds. So just some case, if we print something here, so this will not finish the document. And let's hope, in this case we'll go into endless loop, and the program will, it will crash on after some time, but we can see that this will go to the endless loop, because this is always true. As you can see, the program will, you can terminate it manually, but in general you will see that endless loop is here. And that's because the condition is always true. So until this condition is true, the loop will not be stopped. So maybe I will highlight it as a separate case. And I will comment it, so you can check it after the lesson if you want. So the variable, the declaration of the variable, the true or false, while this is true, we go inside and we do the action. And the question from Memo, what does I++ do? This just increment the I, so I++ means the same, this is the same as I equals I plus 1. So it just adds 1 to I. So increment I by 1. So after each, and yeah, this is really important that it happens after each iteration. So we start with 0, we check if condition is true, and we go inside. First step, done. Until after this action is done, this action will also be done. So we finish all the logic inside the loop. Then it is finished. We increment by 1, and we go to the next iteration. We check if I is less than 5. If yes, if it's less than 5, if it's still less than 5, we again go inside. So yeah, this is the beginning of the loops, and now let's have the break. And after the break, we will continue with the loops. Okay, let's move on. Before we move on with the loops, I would like to show you one important thing related to arrays. So as you remember, I said please distinguish the variable and the object. So the variable is just the place where the object is stored. Like in this case, if we talk about arrays, the variable is the place where the array as an object is stored. So it means that the array is reference. Yeah, that's the object. So let's so imagine we have the array. Just maybe let it be a simple array of strings. Array 1. Let's declare this array. String. Maybe we'll just split the two variables. Yeah. So let's assign the variable to this array. First element is something like name 1, and the second element might be name 2. And now we have the array with two strings, and we can we have the values at each element. So let's imagine we have another array. So now we will declare another array. Array 2. And we we can do it right here. We can do it here. We'll assign the first array. We'll pass the first array to the second array. And let's see what do we have. So if we add and if we change the element, that will be the element 1, the second element of the second array. We'll pass, for example, name 3, and what we see how the second element of the first array will be changed. Array 1, so the first array, and we see how so here you can see that we changed the second element of the second array. And let's see what do we have. Maybe let's print the same result here. And before we do any changes with the second array, let's print out. And what we can see that initially we had name 2 at the second position on array 1, but after we changed the element on the second position of array 2, the value on the second position of array 1 is also changed. So that's the case, and that's the reason for this is because this is the same array. In this case, so as it stands from here, remember after this array 1, array 2, array 1 is the same array as array 2. So now this is the same object, this is the same array. The variables are different, array 2 and array 1 are different variables, but the same array is assigned to them. So the same array is placed on each of these two variables. And we can also see it right here. Yeah, we can check using the check operator. Check if array1 equals array2, and it should be true because we assigned the array from array1 to array2, and at the end we of course have they are the same. Yeah. And that's why, yeah, if we access the array, yeah, we access the same array which is placed under array1 and array2. So if we simply show it here. So these are the variables. So these are the variables, and this is the array. we can declare it using the circle. And now we assign it to the first variable, and it will also be assigned to the second variable. Yeah. So if we declare that this variable is the same as this variable, it means that if this array is placed at this variable, we actually pass the value of the object, the array, from this variable to this variable. So now both of them have the same object, the same array. And that's why if we change the value under the first under the second variable, it will reflect the change in the first variable as well. Again, that's because the same array is placed under each of these variables. So, do you understand this? Any questions? Is it clear for you? Any feedback? Because you don't react, so I cannot really understand if you understand this particular. Not really. That's again. This is the variable. So here you declare the variable. So if you declare just type, then the variable name, this is the variable, right? So this is how we declare the variables. Type, and we have the variable name. So this is the first step. Now we have the variable. So basically, what is the variable? The variable is the place where we store the value. Yeah. So this is the place where the value can be stored. And on the right side, so we have the assignment operator. What does it mean? It means that we pass the value from the right side to the variable on the left side. And in this particular case, so since we declared this variable as a string with the brackets, it means that we can pass the array to this array with the strings to this variable. So this is so in this case, the first point, we declare the variable. So we declared the variable. So this is the just empty variable without any value. Okay. So nothing is inside. Just like if we talk about the boxes, just a box without the candies, without the slots, just a simple box where we can create a structure, put something inside, and so on. So this is the first step, just simple variable without any value. Then we use the assignment operator. It means that we assign the value to this variable. On the right side, we create the value. So in this case, this will be the object. This will be the array. Yeah. The array as the object. So this is on the right side. Yeah, can we use equals? Use equals operator. And then on the right side, we create the array. So here there will be the array. And this, just to make it. So this is the array. Yeah. The array, like in this case, we see there are two elements. So we just simply divide it in two. So element 1, yeah. Element 1, and element 2. So now, and this is the array, this is the object. So we simply place, so at the result, again, we place this array inside the object. So at the result from this, now we have the variable. So this is the variable, the same variable, and inside this variable, now we have the array where there are these two elements, element 1 and element 2. So the slots for the first element and the slot for the second element. So the variable and the value inside, which is placed inside this particular variable. Yeah. So is it more clear now? So again, the variable and the value of this, which is placed under this, variable. And so now, and this is the object, and what we have right here. So here we assigned the variable name 1, name 2. So here we place name 1, now and here we place name 2. So we still have the variable, and we still have the array, but now we access. So again, this is the first level, call level 1. Level 1 is the variable. So variable, again, the place where the value can be stored. Then we have the second level, and the second level is the array. The array as the object where we can place the elements. In this case, we can place two elements. We have fixed number of the elements. We cannot change the number of these elements. So since we created the object, now it has fixed number of elements. So no more elements can be added. And that's why, as I said, so this particular object cannot be changed. Even if you create a new, for example, you create a new array and you assign this new array to this particular variable, this array will still remain inside the system, so it will not be destroyed. This array as the object will remain inside the system. But again, this cannot be changed. Just two elements and no more. But you can change the variables under this element. So this is this is level 1, level 1, level 1, level 2, and the third level is, more precisely, are the elements of the array. So if we pass through the first element, through the first level is the variable. So we are on the second level. The second level is the array, and under the array, using the brackets and using the index, we can access the corresponding element of the array. So this is the last level of the array. The first level is the variable. Then under the variable we place the object. So here we create, again, using new operator. New creates new object. And we assign this array to the variable array1. And for each element we can access using the brackets. So now we initialized the array with the elements, so everything is fine. Right here we declare a new variable. We declare a new variable array2. So maybe let me declare array1, and that's the variable. So this is the variable. And so the next step, so what I do here, I declare a new variable. So now we have a new variable. So this is, again, what is the variable? Variable is the place where we can store the content. In this case, we can store the array. So this is the second array. But what we actually do, we also pass we assign, what we can see here, we assign, where it is, yeah, here, we assign the value from the first array to the second array. So what it basically means, it means that we take the value what is here, and we assign this value directly to the second array. So basically what does it mean? It means that this array is placed under this variable, and it is placed under this variable at the same time. And what it actually means, yeah, easily if we change the element, so if we change, like in this case, we pass through the first level. Again, as you remember, the first level is the variable. We go inside the first level, and then we reach the second level. And the second level is the array. Yeah? But in this case, the array is the same as in this case. So since we access the array, what we do here, we access the array, and in this case, if we access the second array and we access the first array, so this is actually the same array, because we passed the array from the first variable to the second variable. So this means that the array remains the same. And this is the concept for all the objects in Java. So in this particular case, we look at the arrays, but this can be applied for all the objects. Yeah? And why I'm talking about it, because this is really important to understand the concept for all the objects in Java. So if you understand this particular simple case for the arrays, this will remain the same for all the objects in Java. Yeah? For non-primitive data types. So this will be, we have the object and we have the variables. If we pass the object to the variable, then again we have the variable and we have the object which is placed under this variable. The same as for the arrays, it is for strings. Yeah, maybe if we I will show the same thing for the strings. So if we have string, one string variable, string str1, str1, and yeah, I will add more green comment in the code. Yeah, I'll add more green comment in the code. So this is string 1, and let's name one for example. And okay, I mean for strings that will be more tricky, but we will manage to. Yeah, for the strings again, as you can see, this is also the object, but this is the fixed object because it has its own name. In this case, name 1 will remain the same. Will remain the same for all the program. A moment, let me think. Yeah, for the strings that's a little bit more tricky because this is the object. Yeah, at the moment this is the object. This is the fixed object inside the memory. Because again, as you can see, everything is fixed here. So name 1 will remain name 1 during the program. Yeah, for strings that's a little bit more tricky. Okay, maybe we can skip it right now. But the concept again is the same. We have the variable, and for the variable we have the value. And the value in this case is also the object. Yeah, this is also the object. Yeah, I mean I cannot repeat the same trick as for the arrays. Yeah, but when we talk about the objects, we will see so many examples. The same as for the arrays. Yeah, but in this case, yeah, this is static object. Yeah, that's why maybe the strings are really special case of reference types. in Java, but the concept is the same. Basically the idea is that this is also the object. So maybe we'll skip it at the moment. We'll talk about strings a little bit. This is the object. Yeah, because for the strings that cannot really be applied, because as we can see for the arrays, yeah, maybe now we can talk a little bit about the difference between the strings and the arrays. Both of them are reference type, so both of them are objects. Strings are objects and arrays are objects. But what's the difference is? The difference is that the array can be actually, as you can see from here, we can change the elements of the array. For the string, yeah, so we can change the values of the elements inside the array. For the strings, we cannot actually change it because on the right side again, as you can see, this is the object, and now object is name1, so with the value name1. Java is constructed in the way that for the strings, if you type the string, this will have the exact place inside the memory. So name1 is stored in some exact place in the memory, yeah, and it actually cannot be changed. Because if you for the string again, you can. So if you type something like this, yeah, str1 plus suffix, for example. So in this case, this will be so now new object. In fact, a new object is created. Yeah, new object is created. So maybe just to keep the string. Yeah, and now let's check if keep equals string str1. So now using our favorite comparison operator, we can check if keep equals str1, and this is false. This is false despite the fact that, so we can see that we assigned str1 string to keep variable, but then we changed str1, and in this case it actually means that we created new object. So we'll talk about the strings a little bit later, yeah, but this is why it is for the strings. There are, if we want to concatenate the strings, there are some better approaches, not just simply change the strings this way. Yeah. So if you want to add something to the string, as the variable, this will create a new object. So that's the comment. Object located under str1 is passed to the variable keep. So actually this is the object, but in this case new object is created. And as you remember, yeah, I showed this tricky point once. I can show it again. So if we declare a new variable here, and I will comment it out, so because we don't need it. I guess I will just do string1 name and string2 name surname. So in our visualization of the board on the world, yeah. So in our visualization of the board, we can add surname to name, string equals, we can use our plus equals operator. So just as you remember, this means the same as string 1 equals string 1 plus surname. So this is the same, and just to double check at the result, we can see that we will have name surname. String 1. Right. So now again, normally we have name surname. So now the value of string 1 is name surname, because we added surname to name. But so just make a comment. String 1 equals, not use name surname. Well, maybe just to be more precise, value of string 1 equals name surname. But what happens if we compare string 1 to string 2? What happens if we compare these two variables? We'll see that they are not the same. Why? Because when we use this operator, as you remember right here, new object is created. Alright? So we create new object right here. So right here, this is new object, and this new object is not the same as the object created here. So this is really tricky point related to strings, and that's why as I mentioned it last week, for the strings we don't compare the strings using comparison operator. Just again, as you remember, maybe I'll use false, and this will result to false. But for the strings, there's different there's such things like equals, and this will, if we call equals method from the string, this returns us, this actually checks the value. So again, equals, it checks the comment, because equals checks the objects, but true, because equals method checks the value. And this is really important thing, because when we talk about the primitive data types, for the primitive data types, there's no objects. For the primitive data types, we only have the values assigned to the variables. But for the reference types, we have the objects assigned to the variables. And this is a really important thing, because the value of the object is not the same as the object itself. As we see from here. So this is the array itself. This is the object, but the elements of the array are the values. So the same. Just if we quickly also check it here. So just a small example. The integer array. So this is array array 1, and we can assign, just at first. Let's check assign variables to turn free. Assign values turn free. And for with array2 we also can assign values to and from. Let's check if our comparison operator returns the same, and returns true. So array1 checks if it equals to array2. String reference. Oh no, it's not string, that's array reference. So that's not true, because actually when we create a new array, the same is for. So now these are two different arrays. That's false, because despite the fact that the values are the same, it does not check the values. It checks the arrays. In this case, there are two different arrays, despite the fact that the values are the same. The same is for strings. Yeah, again, as you remember, for the arrays, different arrays. The same is for strings. Despite the value is the same, the value is the same, but the objects are different. And yeah, this is because here we constructed, we built a new object here, new string, and that's why they are different. But just if we comment it out and names and print surname, in this case this is the same object as this one, and if we check them now, they should be the same. Why? Because the right side for both of them is the same, so we assign the same object. So name surname, it is considered for the strings. Yeah, it is constructed in such a little bit crazy way that the exact string remains the same as the object. So this is really tricky to think about strings, and based on the strings, I think it's really nice way to understand that the object and the variable is not the same thing. So if you understand this concept, not only for the arrays but for any object, then you will. So this is the base, and this the base for object-oriented programming. And if you understand this one, you will have really huge power in object-oriented programming, and you will understand it, if not easily, then you will understand it. Yeah, you understand object-oriented programming in general. Okay, so this is the start for the arrays, and this is also. So now we can go to the loops. Continue with the loops. Yeah, again, if something isn't clear, please let me know. Okay, so for the array, for the loops, there are different possible options. Yeah, we just we'll just go through option 4. Again, for several times, repeat the same thing. Yeah, this is what we just written. A starting value, condition of repeat, iteration step. So every action what I need to. So first of all, I need to create the variable. Yeah, without the variable, we cannot proceed. So this was. Oops. Yeah, actually, in theory, we can. There is also the option where we do nothing. But what we have here. Let's do some action here. And what we will have here same way we have endless loop. So if you want to create endless loop, you can simply use this simple decoration. So this results in endless loop. Maybe I will comment it out. Also, in some cases, endless loop is needed. We will see why and when. But just that's for the testing. For the testings, if we want to test the program, we can create endless loop. But I will mention you the cases where this may be needed. And yeah, so this is the general state of the decoration. Next, during the next session on Wednesday, I will also explain you and introduce you with such really important thing in the programming like debugging. Maybe you heard about it. But since we just started the loops, now we are ready to also take a look on the debugging. This will be during the next session. At the beginning I will introduce you with debugging, really cool feature and really useful to test the code, especially for the cycles. But yeah, so first of all, let's continue with cycles. So the loop, the first option. And yeah, so as an example, this will repeat iteration 5 times. So we start with decoration, we declare I and initialize it with 0. Then we check is I less than 5. Or so basically it means since I is 0, it actually checks if 0 is less than 5. Yeah, it's true. Repeat loop. So we are inside the loop. It repeats the loop, and at the end of the loop, it increments the value of I. It adds 1 to I. Second step, when I is 1, then again it checks on the second position if 1 is less than 5. It's less than 5, that's true. We repeat the loop. So we repeat the action that is inside. At the end, I is incremented by 1. And this happens for 5 times. And at the end, I is 5. Then we see that I is not less than 5, so the loop is stopped. And that's it. So just a question for you, how many times this loop will be performed? So please answer. Please count and answer. How many times? Any guesses? The answer is 3. Because again we start with 7. 7 is less than 10. So that's the first iteration. The second iteration is 8. So we check if 8 is less than 10. That's true. So that's the second iteration. The third iteration is I equals 9. 9 is less than 10. So it goes inside. On the fourth step, we check if I is 10, yeah, and we check if 10 is less than 10. Is 10 less than 10? No. That's why we skip the last iteration. We can easily check it right here. So yeah, we can simply copy paste this one. I will just simply print out the values of I. Print the values of I. We just do not. Yeah, I will add print. I'll add the comment here. Print the values of the array. And yeah, this will not affect our program. And we can see 3 times. Yeah, for this when I is 7, and the next time I is 8, and the last time I is 9. Yeah. So we start with 7. We can implement some different actions here. Say if we start with 0 again, then we can maybe use it for iterate for 10 times, not 10 until I is greater than 10. And so in this case we just incremented I by 1. We can also multiply I by 2 every time. Why not? So in this case, let's print out all the values of I. That equals 0. So in this case, we can see that oh yeah, that's because I is let's start with 1. No, let's start with, let's start with 1, yeah, that's correct. So yeah, maybe the question for you, why do we have endless loop here? So can you guess why do we have endless loop of zeros here? In this case, yeah, if we have I equals 0. So any guess why do we have endless loop? Yeah, that's correct one, because we add each iteration, yeah, at each iteration. I equals I times 2. But since we start with, if we start with I equals 0, it means that I will always be 0. Yeah. 0 because 0 times 2 is 0. If we start with 1, so in this case we should not have endless loop, because every time this will multiply I by 2. Yeah? So on the first step I is 1, and the second step I is 1 times 2, this is 2. And at the third step I equals 2 times 2, which is 4. And at the last step, I equals 4 times 2, which is 8. And after that, I is 16. 16 is greater, it's not less than 10. So it will actually stop the loop. The same, I will just comment. You can just to test by yourself. You can uncomment it and test it. We can also go in opposite direction. Yeah, we can start from that would be from 10, and then we can check until I is greater than 0, and here we can decrement. So then we can see that this will print us all the values from 10 to 1. Yeah. So here we can also go in the opposite direction. So again, we start with the initial value. The initial value will be 10. Then we check until I is greater than 0. We decrement I. So then we go from 10 to 9 to 8 to 7 and so on. So whatever action we want to perform. So the same way we can also divide I by 2, for example. In this case, we go to 10, to 5, to 2, and then to 1. So we divide, each time we divide I by 2. And basically any operation we want to perform here, we can perform. Yes, because yeah, that's an interesting point. 5 divided by 2 is 2. Yeah, we can also check it using we can print it out. 5 divided by 2. Then I'll comment it out. Yeah, if you want, you can simply uncomment it at home. Since I think we're already at home because we all work remotely now. Yeah, 5 divided by 2 is 2. That's because we divide integer by integer, so we remove all the decimal points. If we divide 5 by, so now we divide double by double, and we have 2.5. That's because now this is double. And for the integer, we cut. For integers, we cut the decimal part. Just simple comment. Result. So this is 2.5. But if we use the integers, for the integers, this is 2. Because this cut. So it just cuts the decimal part after the division. So yeah, you can check different options here. You can decrement. Yeah, we can just it's one of the most popular options is that start here with 0, and then we want to print every second element. Second element, and so this will print us 0, 2, 4, 6, and 8. Yeah, so since this is the variable, again remember this is the variable, so we can also implement some actions inside the code. So in this case we can decrement I by 1, for example, and what will we see? Yeah, we start with -1, and then we finish with 8. So that's because this is also the variable, so we can perform any actions inside the loop with this variable. So any actions we can perform it with I inside the loop. Since this is the variable, but mostly we use loops for the arrays. Again, if we have just as there was the case, thousands and hundreds of students. Just integer array. student grade marks. Yeah. So this will be the array of. This will be the array. There are 100 elements. And if we have the marks from 1 to 10, 10 just for example, as you remember. So again, we go through all the elements. We start with 0. Yeah, please remember this. And so we access each element, and as an example, we can assign the random value from 1 to 10. So in this case, we need to first we need to cast the integer from 1 to 10. So multiple. Okay, maybe let's do brackets now. So what's the issue here? What have I missed? What have I missed here? Okay, just a moment. What am I missing here? Int I. Sorry, it's end of the session. I cannot. It's malicious. So yeah. So in this case, we assign random mark from 1 to 10 to 100 to each of 100 students. So yeah, basically you may ask, why do we have such times 9 plus 1? As you remember, mat random returns the values from 0 to 1. So what does it mean? If we cast it to integer, this will result. The result may be from 0 to 1. But in this case, we want to escape value 0. And in this case, it means that if it returns as 0, it will actually add 1. And so at this point we can get values from 0 to 9, and we simply add 1. So in this case the range is 0 and 9 plus 1, so it results in the range from 1 to 10. Yeah. So now we can skip the brackets so, and now we can check what are the marks for the students. Just simply copy this code. I will not. And then I can also print marks here. Compile this code to not overflow. Oh yeah. Okay. And here we can see there are some random marks from 1 to 10 for 100 students. So we just 100 students. Sorry, yeah, 100 missed. Points on now there will be 100 students. Because yeah, I skipped some of them. So here we have 100 values, and each of them is random value from 1 to 10. Alright. Okay, one moment. I think it is my issue. And okay, where's that one? So that's one. Yeah, my fault. Where's that one? Oh, sorry. So in this case, it must be 10. Alright, yes, now this is from range 1 to 10. Yes, this one, and my final returns greater than 0, it means that it cannot be 0. Yeah. Oh, no, it can be 0, but since we go to integer, this will result in 0, so this will be from 0 to 9, and if we add +1, the range will be from 1 to 10. So here we just simply created random marks for 100 students, and we have all these marks stored inside the array. So this is, so here we print the marks, print all the marks. Here we assigned random marks from 1 to 10 to each of 100 students. Alright, so I will push the changes to the bit bucket, and then you can check it yourself. You can try it yourself. You can try some different options here. Until next session, again, as I stated at the beginning of the session, please send the topics, the points. You can point to each of the example we had during the session. So please let me know what you want to discuss more until next session. And then on Wednesday we can discuss all these topics. Alright, for today, thank you for your attention, and see you Wednesday.